All right, we are still in Chapter 2, Section 1, but now we are in Part B, and we're going to be talking about displacement and distance. So, displacement, we write mathematically as delta x, and it is the straight line distance between two objects, okay? So, it is where an object starts, or its initial position, and where it ends, or its final position. So we write that as delta x equals xf minus xi. Okay. Displacement can be positive or negative, and that depends on our frame of reference. So let's look at our frame of reference and how that determines whether it's positive or negative displacement. Okay. So we're going to have two situations. In this first situation, we've decided that up, the same direction the rocket is going, is a positive direction. In the other situation, we're going to say that this direction is positive. Okay? So in each case, we have our rocket, okay? And he is going to be moving, right? So he is moving in this direction. Okay, and he's traveling in a straight line, so straight line distance is really easy. Okay, so if we call this position XA, and let me see if I can write that a little bit bigger for you. Okay, there we go, XA, and he's made it all the way up to this position here that we're going to call XB. So XA is our initial position and XB is our final position. Okay. So our equation was that delta x, okay, delta x equals x final minus x initial. Okay. So it's moving from XA to XB. So in this situation where it's positive, okay, that means that XB is bigger than XA. Okay, so on this side, XB is greater than XA. Okay, and let's just give those numbers to make it a little bit easier. Okay, so this might be 5 and this is 0. Okay, so over here, our delta x will equal its final position of 5 minus its initial position of 0. Okay, so the total displacement is 5. On this other side now, okay, now we've decided that this is the positive direction, going down. Okay, so even though that's happening, XA is still the initial position, and XB is still the final position. Okay. But now, right, XA needs to be larger than XB, okay? So if we're doing this, we might have set our units so that this was 0 and this was 5. So on this side, okay, we still have our equation, delta x equals x final minus an x initial, okay? But now delta x will be equal to the final position of 0 minus the initial position of 5. And with that, we get that it's a negative 5. In either way, you notice it has the total distance traveled without direction is 5, right? We could say it as the absolute value is 5. So it still traveled the same distance, but with displacement, direction matters, okay? Direction is important. So make sure you know which direction is positive. All the time in physics, we'll use the one that makes sense, but sometimes a couple different ways could make sense. So we'll almost always choose up to be positive. And maybe if somebody's walking, okay, so not going up or down, but the direction they're walking, it's always easier to choose positive. So we'll always choose those two things as a positive direction. But you need to be aware of the difference depending on your frame of reference. All right, so the last thing you need to know about displacement, okay, is that displacement and distance are not the same things. So let's look at an example of that. Okay. Displacement is always the straight line distance between two objects. Distance, on the other hand, is just whatever path you travel, the total length of whatever that path is. So they can be very different things. If your path is a straight line, then your displacement and your distance will be equal. But most of the time in the real world, our distance traveled does not match our displacement. And you could think of it as when you're driving up to school, right? You're coming up the mountain. Maybe this is the mountain on Kong Trail, right? The road doesn't travel up to the school, right? If our school's here, it doesn't go straight up, right? The road winds around and here and there, and you climb up slowly, and eventually you get there. And those are two different numbers. Looking at this just a little bit more. Okay. Let's look at an example of something that you might solve. Okay, so let's say we have our person, and we're going to call him Sammy. And Sammy walks down the road 10 meters, and then he turns left and walks another 10 meters. Okay, and he's almost to where he's going. Maybe he's going to the store or 7-Eleven to get some food. So he turns right and walks 15 meters. Okay, so his distance that he traveled is just the total amount of his path. Okay, so we can say 10 plus 10 plus 15. That is his total distance. So his distance traveled, 10 plus 10 is 20, and 15 is 35 meters. Okay. The displacement now is a little trickier because that's the straight line distance. So let's draw a straight line. Whoops. Let's try drawing a straight line differently here. There we go. Okay. This red arrow is his displacement. Okay. So we're doing displacement in red. So when he does that, we got to figure out how to calculate that straight line distance. Well, we can imagine that we have a triangle, okay? And that triangle will be the same 10 meters, right? And then we can add the 10 meters from above and the 10 meters there. So if we make it a right triangle, we can solve it out. So now this side of the triangle here is 25 meters, and this side of the triangle is 10 meters. So as we solve for that then, all we need to do is use our good old Pythagorean theorem, right? So we'll have 25 squared plus 10 squared will equal the total displacement squared. So D will be equal to the square root of these. And if you plug that in your calculator, you will find that it is 26.93 meters. Now, just remember our discussion about significant figures, okay? I told you in physics we're going to be practical, okay? So this number could give me like 20 decimals if I plug it in my calculator, okay? But I just wrote 2 decimals. And we only got 2 numbers in each that we were given. So if we wanted, we could even round this to 27, but 26.93 is acceptable. So I'm going to write that here for our displacements. All right. There will be more math practice available in another lecture on YouTube here also. So if you feel like you need more practice after this example, just go ahead and check out that video. All right. We'll see you next time.